Thanks everyone for kind of rolling with the room change. I like this room, it's very cozy, so hopefully this will work out well. My name's Dan Gottlieb, I'm a clinical informatician and software developer, and I'm pretty excited today to be able to talk about some work that I've been doing kind of part-time over the last year and a half around creating some standardized ways to assess FHIR data quality and characterization in a FHIR data set. And this work is in collaboration with Boston Children's Hospital and Harvard Medical School, and we've had some great support, oh, my mic's on now, by the Office of the National Coordinator for Health IT and the NIH. So some really good involvement in this project so far, but we're certainly looking for more help if folks are interested in this area. I don't think it's going to come as a surprise to anyone at DevDays that FHIR is expanding into a growing number of use cases. More and more healthcare data is being used in FHIR, and some of that, certainly in the United States, is driven by regulation that requires EHRs to support export of FHIR data in bulk and in kind of patient-by-patient mechanisms, and that's happening all over the world as well in other regulatory environments too. And then there are some really neat projects that are making it easier to work with FHIR data, things like the SQL on FHIR work that is helping to make it easier to use FHIR for analytics. And there's some great talks on that tomorrow morning if you're interested in that area. And then FHIR to OMOP conversion is enabling FHIR as a data source for kind of some existing data analytic pipelines. So lots of use of FHIR. At the same time, there's a lot of variation in kind of the accuracy, comprehensiveness, and structure of FHIR data. So we're not perfect yet. When I was doing EHR implementations, we used to say that every health system is a snowflake. And so each EHR often has extensive customization to work with a particular health system. So even if you have really good mappings at the EHR level, you still may have a lot of data variation when you actually pull your data at a health system. And that creates kind of initial quality challenges. So as you're doing a bulk, as you're exporting data, you may have issues that you need to remediate kind of on your first export. So in one case, we had two institutions that were on the same EHR, but one was generating procedure resources and one wasn't. And it was kind of related to how they were categorizing the data inside the EHR. And so you might want to address that. But then even once you've got your data perfect, you kind of need to monitor your data quality on an ongoing basis. So you might have, for example, a new laboratory that comes online and they're coding their data slightly different using a proprietary coding system instead of mapping to a standard coding system. And so you want to be able to detect that suddenly you've lost a whole category of laboratory results that aren't showing up in your data anymore. So it's important to kind of maintain this kind of monitoring over time. And the goal here is not really to like slap people on the wrist and say your data quality is bad, your data quality is good, of course, but to remediate the data quality. So that might be feedback to vendors around data mappings, or it might be adjustments to mappings within a system. And then if you don't have that ability, you can also do kind of cleaning and transformation in your data pipeline. So if you're getting kind of internal code systems for terminologies and you want standard code systems, you could do that at the system level, but you could also do that in your data pipeline. And then lastly, if you're really getting, you can kind of adjust your analytic approach. So if you're doing a study that could use different types of labs for analysis, and you're getting some labs as coded and some not, you might adjust your study criteria to kind of fit with the data that's available. And so in this qualifier metric set, we tried to develop some standard metric definitions for data quality and characterization. And the idea there is that if you have two institutions with totally different implementations of their data backend, as long as they're kind of using these qualifier definitions, the metrics should be comparable across systems. So it creates that neat ability to have a standard language to talk about data quality. And we focused initially on USCDI version 1 subset, USCDI version 1, which is kind of the current ONC requirements in the United States, implemented in the FHIR US Core Implementation Guide. But that's really around some of the elements in these metrics and not the metrics themselves. And so if you have a different implementation guide and you want to implement qualifier metrics on top of it, we'd love to get contributions to be able to support other implementation guides, other national standards. We put a lot of effort into aligning the metrics with those used in the OMOP world. The OMOP has a decade of work on data quality, and we wanted to make sure that researchers and other folks who are familiar with that really are able to kind of understand and find similar metrics on the qualifier side. We also aligned with, We also aligned with the OMOP folks on the data characterization side. They have a tool called Achilles, and we tried to make sure that most of the metrics that are in Achilles are mirrored in the qualifier metric set with kind of FHIR versions. At the same time, we also added some FHIR-specific metrics that aren't in the, that don't make sense in the OMOP world, but are kind of necessary in the FHIR world, looking at things like reference targets and making sure those are valid as well. So we tried to really tailor this metric set to FHIR. So let's dig into some examples and talk about kind of what we mean by quality, or what I mean by quality metrics and characterization metrics in the real world. This is a laboratory result for hemoglobin in the blood. And I just put in a few examples of questions. So Qualifier covers kind of a lot more than these. But one thing you might want to look at as a very basic check is, are the IDs for the resource, for your observations in this data set unique? So often data will get accidentally pulled multiple times. You'll have duplicates, and then when you do your analysis, it'll look like a patient had 2 lab results of a certain type instead of 1. So a really basic check you can say is like, are our IDs unique? Is the patient reference valid? So if we have a reference to a patient in this data set, do we have that patient that's being referred to? Again, pretty basic check, but really important to understand if you can actually use this data. Dates are kind of a mess in data quality. I feel like there are often issues with dates. So you can ask some basic questions about dates. You can say, like, is this date plausible? Is it in the last century? And we'll actually look at an example in a demo in just a few minutes in some real world data where there was data from a different century because of a data conversion issue. And then because this is a resource associated with a patient, we can ask if the test happened in the patient's lifetime. And you need a little bit of wiggle room there because you have prenatal tests and some tests come in after a patient's died. But you wouldn't expect to see data from 10 years before a patient was born for that patient. And so that can flag some quality issues in your data or date conversion issues. And then my favorite quality check is around clinical plausibility. So when we look at a value here, you can check if that value is even possible for this particular lab code and this unit. And in our test data, we actually found some units that were incorrect because of doing this check and finding that there were values that were just impossible for those units. So that comes up a lot, and certainly checking your code system. It might have the wrong code on it, which would be flagged in a lot of cases by the clinical plausibility check. And we can actually leverage some really great work that's done on the OMOP side, where they've developed a couple hundred of these clinical plausibility ranges, and we can just apply them in the FHIR side as well. Switching gears a little bit to characterization. So quality I kind of think of as things you can check that have a yes-no answer. Is this correct? Is this not correct? Characterization is more about understanding your data to see if it's fit for purpose. So a characterization metric may be good for one use, may indicate the data is good for one use, but less good for another use. So if we look at the same laboratory observation, we might just want to know kind of how many of them are there. So if I'm expecting to be able to run an analysis on labs and getting very few labs back in my data set, that's probably an issue for this use case. On the other hand, if I don't care about laboratory results and I don't have a lot in my data set, maybe that's not a problem for me. Understanding terminology systems is really important, and we'll look at an example of this. So how often is laboratory data coded using a LOINC code? Well, that'll tell me if I can use a LOINC code to query for this data or to pull out a cohort of patients. And if the data isn't coded, then we might need to do some of the remediation steps that we talked about. I want to understand something similar I can do is around the codes. So if I'm using a particular value set, can I expect to get a reasonable quantity of patients with this value set, or maybe I need to adjust my value set or adjust my terminology. And then one of my favorite characterization metrics is around kind of looking at the data associated with a patient. So trying to understand how much of the patient's record is in my data set and how much might be elsewhere. So if I have a lot of patients who don't have any encounters or have one encounter, I might not be able to do a lot of research that kind of expects to understand a longitudinal view of that patient. So that's a really important check for a lot of research use cases. And perhaps not surprisingly, because I'm giving a presentation about this qualifier metric set, all of these questions kind of correspond to metrics in the qualifier world. So shifting gears a little bit, I know I'm moving really fast, sorry about that, I have kind of a limited time. I want to talk about an implementation of some of these metrics. About a dozen of them have been implemented to date that I've been working on with the team at Boston Children's Hospital, specifically a developer there, Mike Terry, who's leading the work, around implementing some of these metrics on top of their Cumulus FHIR data warehouse platform. All of this work is open source, and so you can download it and try it on your own data. And they support kind of two data ingestion methods right now. You can run these metrics on top of a pile of NDJSON data using a tool called DuckDB, and just kind of take a bulk export directly, run these metrics on top of it, and get back some metric data. You can also load the data if you have a large data set into AWS Athena and as FHIR data and run the metrics on top of Athena using the same tool. And what it does is it's a bunch of SQL queries, so it's easy to port to other systems that generate a set of summary tables for quality and characterization metrics, generally one table per metric per measure, per metric per resource. So you end up with a bunch of these kind of fairly small, flat tables, rectangular tables. And then those tables can be used in a business intelligence reporting tool or in some alert metrics to be able to tell you if there are issues with your data quality and also to visualize your characterization. So this tool is kind of one implementation of the Qualifier metrics. Certainly you can implement on top of other tools, and you can also extend this tool in other ways. So because I want to live on the edge, I'm going to try to do a live demo here of this tool. As I said, it's open source and publicly available, so you can try it on your own data if this fails. So if we look at the data we have here, it's just a pile of NDJSON. Hopefully that's big enough for folks to see. A pile of NDJSON. This could be from a bulk export. In this case, this is synthetic data, but we'll look at some real data as well. And then to run the qualifier metrics, let's see, I think I left this in here. Yep. There's a lot of parameters, so this looks complicated, but it's really just configuration options around where you want where your data is, where your files are. We're running on about 100 Cynthia patients, so it should run almost instantly. Yes. And so it's generated a bunch of these tables in a DuckDB database. So we're running directly on NDJSON, generating everything locally, and then can visualize it. And I'm actually going to do kind of a cooking show trick here and switch to a different data set. So we ran that data set on Cynthia, and I could show that data set, which looks really pretty in the visualizations because it's very regular data. But I thought it might be more interesting to take a look at about a 10,000 patient sample that I pulled from a real EHR system at a healthcare institution. So I'm gonna, I put together some visualizations using a tool called Observable Framework, which is an open source tool. That's kind of, these are just kind of some interesting visualizations. You can do a lot of visualizations on these metrics, so it really depends around kind of what your needs are and what BI tool you want to use as part of your workflow. Let's see. Hopefully that'll show. Yes, excellent. All right. Oops. But it is not letting me go full screen, which is awesome. All right, well, I think in the interest of time, I'm just going to run with it here. Oh, I see, okay. It just minimized it for me. Not helpful. Okay, so here we have about 10,000 patients. This is just some characterization metrics on the population. We can see that we don't have a lot of patients marked as deceased in the data set. If there were, they would kind of show up as these bars. We have kind of one or two. This is this is patient population by birth decade, so we can kind of see that a lot of our patients are on the younger end here. You can also see a cut by administrative gender. We see kind of an even split between male and female, which is maybe what you would expect in a general population data set. Deceased status, almost all these patients are alive. We can see that the hospital here is not really capturing ethnicity much. Most of these are listed as none. And that a lot of the patients have asked but no answers. So in the United States, I know in a lot of the world you don't track race and ethnicity for patients. In the United States, we track it to measure health equity. And here, we probably wouldn't have great data for that in this data set. So that's important to understand. We have similar characterization metrics around the FHIR resources. So this is on an exponential scale, but we can see that we have very few device resources, about 6 device resources, so we probably couldn't do a lot of research in that regard, but we have a couple 100,000 vital sign observations. So we probably could do pretty well on vital signs. I'm going to move really fast because I think we're running low on time. But I wanted to flag a couple things here that are interesting. So you can see here that we have a bunch of encounters from the 1800s, which seems not plausible. Actually, that's the result of kind of some defaults on importing data from an older system. And we'll also see that flagged in the quality. So you don't necessarily have to dig through characterization metrics to find things like that. This is the metric that I talked about that I really like, looking at resources per patient. Here we're missing some standard deviations to see how clustered the patients are around the averages. But we can see even by looking at the max numbers, we have an outlier here of a patient with 20,000 vital sign observations. And so that's something we're actually going back and looking at, like what the deal is there. Are they a test patient? How did that get in the data set? I don't have an answer yet, but that's a question that we actually need to look at for real with this data set. So those are characterizations, right, that don't have yes, no answers. Quality metrics, this is a summary of some of the quality metrics in Qualifier. And one of the interesting ones we can look at here is reference targets. So this is the question of, are these references, like from allergy intolerance to encounter and to patient, populated with resources that are in the data set? And here we can see it's pretty good. We have 1% of diagnostic reports don't have an encounter that's not in the data set, so that's something we would want to investigate as well. I'm going to show two more visualizations that I think are pretty neat. This one looks really messy, but it's actually really interesting. Hopefully folks can read this. I can make it a little bigger. So this is looking at terminology system use by resource type by a codable concept. And so here we can see, like for allergy intolerance, about 32% of our codes have no system associated with them. They're just text codes. And so that might be a problem if we're trying to look at allergies in a structured way. With the rest of the codes, we can see about 11% of our RX norm and about 60% are SNOMED. And so if we're not looking at the uncoded data, this kind of indicates that it's a big enough percentage that we might need to look at both systems in order to get a good picture of the data. And we can rotate this by system or by resource type. So I can filter to SNOMED and see kind of where SNOMED is used in my data set and to what percentage. So for example, on conditions, I can see that we have like 85% coverage with SNOMED. So that might be a really a resource type that we can query really well using SNOMED codes. And then I wanted to show kind of one more view that I put together here. This is looking at the mandatory and must support elements in US core and when they're populated. So again, characterization, understanding kind of which pieces of the data are really useful in research. And so here I can filter, let's say we want to look at allergies again. I can see that most of the mandatory elements in US core are populated across the entire data set. So those are really good to use in analysis. But if I cared about reaction manifestation, I can see that that's only populated 6% of the time. And so that's a field which I wouldn't want to be depending on for my analysis, or I would want to remediate at the EHR level, either mapping or data input or something like that. So I think these characterization metrics are really helpful in kind of understanding kind of what types of analysis you can do, whether your analysis is going to be able to be worked across data sets, and whether you need to make adjustments kind of site to site. So I'm going to switch back to the slides for my last minute or two here. And talk about next steps. This Cumulus Q work, which is the implementation of Boston Children's, is still pretty early stage, so we certainly want to expand metrics coverage. About a dozen of the qualifier metrics are covered currently. The qualifier, we've actually been cleaning up the qualifier definitions as part of the implementations, which is what you would hope would happen. Certainly some refinement could still happen on the qualifier side, and looking for contributions from folks who are trying out these metrics. And then on the SQL performance side, for the local data set, it's currently memory constrained, and I think we'd like to be able to work with larger data sets locally in addition to in Athena and in the cloud. So if you're interested, I encourage you to check it out. You can test this Cumulus Q implementation against NDJSON files without having to kind of set up any kind of major infrastructure. You can run it all locally on your machine. If you do have an environment where you want to run metrics, the different data warehouse in the cloud or something, a Postgres system locally, these metrics are all kind of pretty basic SQL, so they can get ported to other systems as well. You could also do kind of a totally different implementation of the same metrics using the qualifier metric definitions. So you could have implement the same metrics, but just with a totally different back end, and that would allow kind of comparison across institutions and also contribute back to the community to having a really good set of standardized metrics. So I think there's still a lot of work to do. This is pretty early stage work, but I think it's important for us to have kind of a language to talk about data quality and data characterization in the FHIR world, and also to really make sure that we're assessing this well before we start using the data and passing along the data to other parties. So I think I'm basically at time, so I'll leave it there. I don't know if we have time for 1 or 2 questions, or I'm happy to hang around afterwards. Time? Okay, thanks.